Okay, let's take a look at factoring quadratic trinomials with a leading coefficient equal to 1. First of all, a little bit of vocabulary. When we see the word quadratic, you should understand that that means that our greatest exponent is basically 2. Trinomial means we have 3 terms in our expressions, and the leading coefficient is basically the coefficient of the term with the highest degree or power. And we'll go through an example in a moment. Let's look very specifically. Quadratic trinomial. It's a trinomial of the form ax squared plus bx plus c. So we're going to have our problems basically in this form, where a, b, and c are any real numbers not equal to 0. Let's write out an example. Suppose that we've got a equal to 1, so it'll end up being 1x squared. Suppose we have b equal to 3, so it'll end up being 3x. And suppose that we have c equal to 2, so we're going to have a 2 at the end. This is an example of a quadratic trinomial. And what we want to be able to do, of course, is we want to be able to factor this. So what do we do? Well, to be able to factor something like this, keep in mind the leading coefficient in our problems is always going to be 1 in this particular lesson. What we want to do is look at an example with the FOIL or the distributive property. So let's look at what's underneath the squiggly line. Here they want us to multiply this out. And so, ladies and gentlemen, I want you to go ahead, take a moment, pause the video, and multiply this out, combine like terms. Okay, hopefully this is what you did. X times x, x squared. X times 4, 4x. 3 times x, 3x. 3 times 4, 12. Now, if we combine these like terms together, we're going to get x squared plus 7x plus 12. Now, our goal today is to basically do this multiplication process in reverse. We need to be able to do this backwards. And so we want to study the patterns in this particular problem. And specifically, there are 2 questions we want to take a look at. Here they are. The first question, where does the 7 come from in the original problem? Think about it. Well, hopefully you said that the 7 really came from the 4x plus 3x. That gives us the 7x. But the 4x and the 3x we got by basically multiplying here. And when we multiply it out, we ended up basically adding the 3 and the 4 together here to get that 7. And so the 7 really comes from taking the 3 and the 4 in the original problem and adding those together. That's what happens when we clean this up. How about the 12? Where does the 12 come from in the original problem? Well, hopefully you said the 12 just comes from multiplying 3 times 4 together, because originally when we did 3 times 4, we got 12. And then we brought down the 12. So the 12 really comes from multiplying. And so I'll write multiply there. Now, this idea of add and multiply is exactly what we need to do backwards to do our problems today. And so to do our problems, what I do is I call this simply the add multiply method. And I'm going to refer to this a lot, the add / multiply, abbreviate their method. Now, ladies and gentlemen, at any time, feel free to pause the video and try to do the problems that we're doing ahead of time if you'd like, if you think you're in pretty good shape here. All right, let's take a look at some examples. Here we've got 2 examples, and let's take a look at the example on the left right here. We want to be able to factor this out. And notice that this problem is exactly the same as our example right here. And so what do we do to factor this out? Well, I want you to realize that the leading coefficient is 1. The leading coefficient, it has to be 1 to use that add multiply method up here. And because it's 1, all that I'm going to do is I'm going to go ahead and look at the pattern here. we need to find numbers that add to that middle term right here, commonly called the linear term, 7x. So I'm putting an A here for add. And we need to find numbers that multiply to our constant, which is our number at the end here. So I'm going to put an M there for multiply. Now, what I always tell students to do is do the multiply first. Why? Because there aren't that many factors of 2. So let's give this just a little bit of thought. What are some numbers that multiply to positive 2? Well, 1 times 2 comes to mind. Also, -1 times -2. And these are the only factors of 2. Notice we're just using integers here as factors. No fractions, no decimals. Now, we've got those numbers that multiply to 2, these pairs of factors, but only one of those pairs is going to add to 3. So think back. Which one adds to 3? If we made this a plus sign instead of a times sign, is that going to add to 3? Absolutely yes. And so these are the numbers that we're going to go ahead and put inside our parentheses for the answer. And now the hard work has been done. Let's write out the final answer. Where do these numbers go? Basically, these numbers go right here at the end in our problem. So let's go ahead and write it out. We have a positive 1 here. It's a positive 1, so I'm going to put +1 right here at the end. We have a positive 2 right here, so I'm going to put a positive 2 right here at the end. And we can put x and x. And that would be how we do this. Now, you could also write your answer as x plus 2 times x plus 1. Both answers are the same. All right, ladies and gentlemen, here's what I want you to do. I want you to pause the video, try number 2, then we'll go through that. Okay, let's go ahead and take a look at problem number 2. What should you have done? Hopefully you notice, hey, my leading coefficient is 1, and so I'm going to use the add multiply method. And so I need numbers that add to 8 and multiply to 15. And so now I'm going to think about numbers that multiply to 15 because I know that I'm going to do my multiplication first. Why do we do the multiplication first? It's very straightforward. There aren't that many numbers that multiply to 15 that are integers. We got 1 times 15. We got 3 times 5. We have -1 times -15. And we have -3 times -5. If you didn't do this first, if you found numbers that added to 8 first, you would have a list infinitely long. 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4, 9 plus -1, 10 plus -2. And so do your multiply first. Let's go ahead and now find the pair that adds to 8. If we add these up, do we get 8? No. If we add these up right here, we obviously get 16. If we add these up, do we get 8? Yes. So these will be the numbers inside our parentheses. Let's go ahead and write this out here. The positive 3 is going to go in one of the parentheses. The positive 5 is going to go in the other parentheses. And we'll put an x and an x there. And there we have it. All right. Ladies and gentlemen, here's what I want you to do. I want you to go ahead and try this next one. This next one involves negative numbers, but you're going to do it very similarly. So try number 3 on your own. Pause the video, then we'll go through that. After a while, you can do a lot of this work in your head. Begin now, please. Okay. Ladies and gentlemen, let's go ahead and now take a look at problem number 3. What we're going to do is find numbers that add to -10 and multiply to 21. And so I'm going to do my multiply first. What integers give us 21 as a product? Well, 1 times 21, 3 times 7. We got -1 times -21, and -3 times -7. Of course, after a while, you're able to do this work in your head. And that's a point that everybody should be able to get to. But that takes practice. All right, now we can go ahead and figure out which pair of numbers adds to -10. So which pair gives us a negative 10? You got to add these up in your head, and obviously this right here is going to be the pair we're going to use. So x minus 3, x minus 7, and that's it. Now, how can you check a problem like this? You could check this problem by just multiplying it out. And often teachers don't have enough time to go through this in class right here, but I'm going to briefly do this. If we multiply here, x times x, x squared, x times negative 7 minus 7x, negative 3 times x minus 3x, negative 3 times negative 7 plus 21. Let's combine the like terms together. X squared minus 10x plus 21. And notice the answer that I got is exactly the same as the original problem. And this is a good way to check and make sure that you're doing your problems correctly. All right, ladies and gentlemen, try number 4. All right, let's go through problem number 4 similarly right here, see what we could do. In problem number 4, we want numbers that are going to add. And what's my coefficient here? Well, there's nothing there, so it'll be a 1. What adds to 1 and multiplies to negative 6? And again, I've said this before, I say this a lot in class, there's nothing wrong with writing out your factors here. After a while, hopefully you can do this in your head. To get negative 6, we could go negative 1 times 6, negative 2 times 3, negative 3 times 2, negative 6 times 1. And now, which pair adds to positive 1? Well, if we add these together, these give us a positive 1. So we're going to write x minus 2 and x plus 3, and that's it. All right, ladies and gentlemen, let's take a look at a couple of tougher ones. If you're looking for tougher ones, these next ones more challenging. Try number 5. All right, let's go ahead and take a look at problem number 5. We'll do this obviously like we did the earlier ones. Let's try to do this in our head. We want numbers that add to negative 2 and that multiply to negative 24. And as we take a look right here, because the last number is negative, obviously the only way to get a negative answer when we are doing this multiplication process is for one number to be positive, the other to be negative. And so we'll keep that in mind. Now, to get that negative 24 right here, if you think about it, and you may need to write out the list, it'll be negative 6 times 4. These multiply to negative 24, and these add up to negative 2. So x minus 6 and x plus 4. And that's it. And again, there's no shame in writing out the entire list. At the beginning, that's excellent practice. All right, try the last one. Number 6. Pause it. All right, let's take a look at number 6. Add to negative 18 and multiply to 32. What's going to work? Well, if you give this some thought, negative 2 times negative 16 is going to multiply to 32, add to negative 18 rather. And so x minus 2, x minus 16. All right, ladies and gentlemen, with practice, obviously this gets easier. Keep in mind that you can only use this add multiply method if your coefficient, your leading coefficient is a 1. All right, ladies and gentlemen, make sure that you work hard. Bye-bye.